At first glance, this graph looks convincing. As study time increases, test scores also tend to increase. So it's tempting to jump to a conclusion: studying more causes higher scores. But this is exactly where the SAT wants you to slow down. This graph shows a relationship, but not a cause. We see that students who study more often score higher, but we don't know why. Maybe stronger students choose to study longer. Maybe students with better support both study more and score higher. Or maybe another factor is influencing both. The key lesson is this: correlation can suggest a pattern, but it cannot prove causation. On the SAT, your job is not to explain why something happens, only what the data actually supports. Let's slow down and be precise about what this graph can, and cannot, tell us. A scatterplot like this can show a pattern. We see that as study time increases, scores tend to increase as well. But the graph does not explain why that pattern exists. There could be a third factor, like motivation, prior knowledge, or access to tutoring, that affects both study time and test scores. Or it might be that stronger students naturally choose to study more. To prove causation, we would need a controlled experiment, where study time is the only thing that changes. Without that, all we can say is this: the variables are related, but one does not necessarily cause the other. And on the SAT, saying causes without proof is a mistake. This is where the SAT becomes dangerous. The test often uses causal language to tempt you into overclaiming. Words like causes, leads to, or results in sound reasonable, but they go beyond what the data can prove. A scatterplot can show association. It can show that two variables move together. But it cannot tell us that one variable causes the other. The safe, correct language uses phrases like is associated with, is related to, or tends to. On the SAT, choosing the wrong verb can turn a correct idea into a wrong answer. So remember, correlation allows description, not explanation. Here's a powerful SAT strategy you should lock in. First, eliminate answers that use causal language. Words like causes, leads to, results in, or makes are red flags. They go beyond what the data can actually prove. If the information comes from a table or a scatterplot, the SAT is almost never asking you to prove cause and effect. Instead, prefer answers that use association language. Phrases like is associated with, is related to, shows a relationship, or tends to describe patterns without explaining why they happen. Here's the quick SAT rule to remember. If the data come from a table or scatterplot, causation is almost never justified. Spot that trap, and you can eliminate wrong answers fast, often before you even start calculating. Here's how to think about correlation and causation on the SAT. First, identify the claim. Ask yourself, is this statement describing a relationship, or is it trying to explain a cause? Second, check the data source. If the information comes from a table or a scatterplot, you are almost always limited to association, not causation. Third, match the language carefully. Words like causes or leads to explain why something happens, and that goes beyond the data. Instead, look for language like is associated with or tends to. These describe patterns without making assumptions. And finally, eliminate aggressively. If an answer tries to explain the reason behind the pattern, cross it out. Remember, on the SAT, the correct answer tells you what the data show, not why it happens. Before we move on, let's pause and log in the key ideas from this section. First, correlation describes patterns, not causes. A table or a scatterplot can show that two variables move together, but it cannot explain why that happens. Second, always pay attention to the language of the claim. If an answer choice uses words like causes, leads to, or results in, that should immediately raise a red flag on the SAT. Third, remember the core SAT mindset. The correct answer describes what the data show, not what you think should happen, and not what sounds reasonable in real life. These ideas may feel simple right now, but the SAT is very good at testing whether you can apply them under pressure. So next, we're going to practice. We'll start with a beginner-level question, then move to intermediate, and finally an advanced problem where wording and context really matter. Take a breath, and let's put this thinking to work. Take a moment to study the scatterplot on the right. It shows the relationship between hours of smartphone use per day and hours of sleep per night. Now read the question carefully. Which statement is best supported by the data? Before you look at the answer choices, pause and ask yourself, what does this graph actually show? Do you see a relationship? Yes. Do you see a cause? Be careful. As you review the choices, pay close attention to the language. Some options try to explain why this happens. Others simply describe what the data show. Remember, the data can show patterns and associations, but they do not prove cause and effect. You have 60 seconds. Pause the video and choose the best answer. Let's look at the answer. The correct answer is B now. Here's why. When we look at this scatterplot, we see a negative relationship between smartphone use and hours of sleep. As smartphone use increases, the number of hours students sleep tends to decrease. That's exactly what choice B says. Students who use smartphones more tend to sleep fewer hours per night. Notice the language here. It does not say, causes. It does not say, will happen. It simply describes the pattern we see in the data. Now let's quickly see why the other choices are incorrect. Choice A says that using smartphones causes students to sleep less. But this graph cannot prove cause and effect, only association. Choice C predicts what will happen if smartphone use is reduced. That goes beyond what the data show. Choice D reverses cause and effect, claiming that sleeping less forces students to use smartphones more. Again, there is no evidence for that direction. So remember this key rule. Data can show association, not causation. On the SAT, always choose the answer that describes what the data show, not what they might explain. Let's move on to beginner practice, question 2. You'll have 60 seconds to think, so first, make sure you understand what the graph is showing. Take a moment and look carefully at this scatterplot. On the horizontal axis, we have hours of smartphone use per day. On the vertical axis, we have hours of sleep per night. Before jumping to any conclusion, pause and ask yourself one key question. What does the data actually show? As smartphone use increases, what seems to happen to sleep time? Is there a clear pattern, or just random points? Now be careful. This question is not asking why this happens. And it is not asking what will happen if someone changes their behavior. Look only at what the dots show. Do students who use smartphones more tend to sleep fewer hours per night? Or does the data claim something stronger, like cause and effect? Read each answer choice slowly. Pay close attention to the language. Words like causes, will, or forces go beyond what a scatterplot can prove. Choose the statement that stays faithful to the data, and nothing more. You have 60 seconds. Pause the video and decide. Let's go to the answer for beginner practice, question 2. The correct answer is C. This question is not asking you to explain the relationship. It's asking you to choose the statement that stays closest to what the points actually show. So we focus only on the condition in choice C, students who use smartphones more than 6 hours per day. When you look at the points to the right of 6 on the x-axis, you can see that most of them fall below about 6.5 hours on the y-axis. And notice the wording, most, and about. That's exactly the kind of careful language a scatterplot supports. Scatterplots show patterns, not perfect rules. Now, why are the other choices wrong? Choice A says sleep decreases by exactly 1 hour for every extra hour of smartphone use. But the points don't form a perfect line, there's clearly variation. Choice B says the data prove smartphone use causes less sleep. A scatterplot cannot prove cause and effect. And choice D uses the word always, but you can see at least one student under 2 hours of phone use sleeping less than 8 hours, so that statement fails. So the key takeaway is simple. On the SAT, pick the choice with wording that matches the graph, most and about, not exactly, prove, or always. Take a look at the scatterplot. It shows the relationship between daily smartphone use and average sleep duration among high school students. Your task is to decide which statement is best supported by the data. Be careful. The graph shows a pattern, but it does not explain why that pattern exists. Read each choice closely, and watch for statements that go beyond what the data actually show. You have 60 seconds. Pause the video, study the graph, and choose the best answer. Alright, let's move on to the answer for this intermediate practice question. The correct answer is C first. Focus on what the scatterplot actually shows. It compares daily smartphone use with average sleep duration among high school students. Overall, the points trend downward. As smartphone use increases, average sleep tends to be lower. But here's the key idea for the SAT. A scatterplot like this can show a relationship or an association. It does not prove what causes what, and it does not tell us the reason behind the pattern. That's why choice C is best. It stays strictly within the evidence in the data and describes the association, nothing more. Choice A is incorrect because it claims a primary cause. The data do not support causation. Choice B is incorrect because it adds an evaluation, sufficient sleep. The graph shows hours, but it never defines what sufficient means. Choice D is incorrect because results in is also a cause and effect claim, which cannot be inferred from this scatterplot. Here is your advanced practice question. The scatterplot shows the relationship between weekly hours of part-time work and average test scores. Which statement is best supported by the data? Take a moment to study the graph carefully, then pause the video and choose your answer. Alright, let's go over the answer for this advanced practice question. The correct answer is D to see why. Focus carefully on how the pattern changes across the graph. At lower work hour levels, the points are widely scattered, and there is no clear relationship. However, once students work more than about 15 hours per week, a clear pattern appears. In that range, higher work hours correspond to lower average test scores. Choice D correctly describes this conditional relationship. It stays within what the data show and does not explain why the pattern occurs. Choice A is incorrect because the relationship does not hold across all work hour levels. Using tend to for the entire group is too broad. Choice B is incorrect because it overgeneralizes. The association does not apply to all students, only to part of the data. Choice C is incorrect because it claims a cause and effect relationship and predicts the result of an intervention, which the data do not support. On the SAT, even association language must match the scope of the data exactly. Let's wrap up with the key takeaways from this lesson. First, remember that correlation describes patterns, not reasons. A scatterplot can show how two variables move together, but it never explains why. Second, causal language is never supported by a scatterplot alone. Words like causes, leads to, or results in, should immediately raise a red flag. Third, even words that sound safe, like tend to or associated with, can still be wrong. What matters is not the word itself, but whether the statement matches the data exactly. Fourth, always check the scope of the claim. Ask yourself, does this apply to all students, or only under certain conditions? If the data support a relationship only in part of the graph, the statement must reflect that. Finally, on the SAT, discipline matters more than intuition. Say only what the data truly support, and absolutely nothing more. That mindset is how you avoid traps and earn points.